Okay, people listen up. You got a couple of your peers taking the test, so I suggest you be nice and quiet, okay? Secondly, I'm also recording, so let's make sure that this gets recorded as really a lesson, not a zoo class, okay? Several new concepts to go over, okay? For those people who've taken stats, you should already know this stuff, okay? So it should be fairly easy. So I want to go over factorial notation first. So get this down and then I'll explain it to you. What this means, okay? So supposing, for instance, you had 8 factorial, okay? Then that means you're going to take 8, 7, 6, 5, 4, 3, 2, 1. You'd multiply that all out, okay? Or alternatively, you can even say it is 8 times 7 factorial, and you can stop there, and that's understood that that's the same thing. Now, what I want you to do is get your scientific calculators out, get your graphing calculators out, find out where the factorial notation is in each one of them, calculate it this way. I mean, just by putting it in your calculator, 8 factorial, and then calculate it this way by doing 8 times 7 factorial and show that the two are equal. Question, Ryan?
How does 0 factorial equal?
We will go through that in a minute once you verify that this is true.
Okay.
Is everybody all right on this? Okay. To answer Ryan's question, does everybody understand this? Does everybody understand that? Does anybody want me to explain that? Okay, in other words, what it's saying is start out with n, and then multiply it by reducing n by 1, and then by another 1, and then by another 1 until you get down to 1. You guys with me on that?
Yeah.
Okay. Oh, wait. Is everybody there? Burroughs, you don't look like you're there. All the way. If you keep decreasing numbers, don't you get down to 1? You start with an integer. If you decrease by 1, don't you get down to 1? Okay, so go down until you get to 1. Okay? Is everybody with me on this? Okay. Now take a look at this, okay? Take a look at this. Now before you yell this out, stop there, think, and see if you understand this. If not, I will explain. Do you understand this line here? Do you understand that line? Sina, are you saying yes, no, or maybe? No?
Wait, is that n?
Oh, you mean you kind of missed him? You didn't even miss him? Sina, see, you're totally useless. They don't even miss you if you're gone. Yeah, no, he's gone. Okay, so Sina, do you understand? Yo, can you guys S up and focus for 2 minutes? Do you understand that? What's the difference between this and what I have there? Except instead of 8, it's an n. Right? So you start out at n plus 1, you reduce by 1. If you reduce n plus 1 by 1, do you get n? Is everybody with me on that? N factorial, just like it's here. You guys with me on this so far? Yeah. Okay. Does everybody agree then that n factorial is equal to n plus 1 factorial over n plus 1 by isolating n factorial? You guys with me on that? Okay. See how I isolated this, Ryan?
Oh, yeah.
Okay. See how I isolated that? Is everybody with me on this? Yes? If now, Stephanie, if I put n equals 0 in here, then I get 0 factorial? Yes? Because n is 0, I'm telling you it's 0. Or let's say it is 0. What do I get on the right hand side for the numerator? 1 factorial? What do I get downstairs? 1. What's 1 factorial equal to? 1 over 1 equals 1. 0 factorial equals 1. Isn't this smart? Yes. Okay, is everybody okay? So does that answer your question, Ryan?
Yeah.
Why 0 factorial 1? There it is. Ryan, I got to compliment you on this. Over all the years that I've taught this class, nobody's ever asked me why 0 factorial is 1. Never. Never. So I'm really proud of you. Really proud of you. Wait a minute. Let me pose this. It's what? It's just oil? It's just grease? Okay, so does everybody see that the numerator is this? Is everybody happy with the numerator? 8 times 7, 6 factorial. I don't want to go down all the way to 1, and you'll see why in a minute. Yeah, exactly. All right, is everybody there? Then what's 2 factorial equal to? 2 times 1 is 2. And then I have a 6 factorial as well. Well, the 6 factorials cancelled. There was no need for me to go all the way down to 1. And so the 2 and the 8 cancel to give me a 28. Okay? So we're going to use the same technique to do this other problem. Okay, there are no numbers there, it's all algebra. So I'm going to go n plus 2. I'm going to reduce it by 1. What do I get? N plus 1. I'm going to reduce it by 1. And I'm going to stop there because I have an n factorial downstairs. So that cancels. And this gives me n squared plus 3n plus 2. Okay, so your 84 cannot do this stuff. Okay, 84 cannot do it. All right, you guys caught up with me? Yeah? Huh? What? Trying to get a factorial or? Yes. No, it's you start from n and you reduce by 1. And then you reduce by 1. But I'm starting out with n plus 2. So you reduce by 1, you get here. You reduce by 1, you get there. Yeah. Okay, so remember what 8 factorial means. Okay, you're going to go start with 8. You're going to reduce by 1. Right? You're going to reduce by 1. You're going to reduce by 1 and so on. So you start out n plus 2, reduce by 1, you get there. You reduce by 1, you get there. Why did I stop here? I stopped there because my downstairs is the same thing. So there's no point in me going further. I can cancel those things out. All right, is everybody okay? All right. The next concept, which is summation. Okay, I can't emphasize enough how important this concept is, because when you come back next year as a senior in calculus in September, you're going to start out with this notation. That's the very first thing that you're going to do. Okay, within the first week or two. Okay, so you really want to pay attention to this section because we use ideas from here again next year and throughout the year, as a matter of fact. Throughout the year next year. So what I want to do is I want to show you how to write this thing here in shorthand form. Okay, in shorthand form. So notice that this is really a series. Yesterday I defined to you what a sequence was. Does anybody remember what a sequence is? What is a sequence? Sorry? A set of numbers that have a pattern, exactly. Okay? This is actually called a series, and we'll see this definition again in a minute. It's called a series. A series is nothing more than a sum of a sequence. Okay? So a sequence is a bunch of numbers. A series is just a sum of those numbers. That's all it means. Okay? It's some pattern. So you know that the sequence is made up of 1, 2, 3, so on, all the way up to 100. So can someone give me the formula for a sub n? Remember, a sub n just means the nth number in that sequence. What do you think it's going to be? What's it going to be? What's it going to be, people? Whoa. Yeah, Leila? In functional form, okay, in functional form. Sorry? It's just n. It's just n. Alright? It's just n. Because if n is 1, you get that. If n is 2, you get that. If n is 3, you get that. So you can actually write this thing, 1 plus 2 plus 3, and so on, plus 100, as sigma. N starts out with 1, goes up to 100, and that becomes n. Okay? That becomes n. So in other words, this is the shortened form for writing 1 plus 2 plus 3 all the way up to 100. Okay, all the way up to 100. Just leave it there. Okay, is everybody all right on this?
1 second.
So the way you read this is sigma n starts from 1, goes up to 100. That's how you read it. Sigma n equals 1 to 100.
Wait, so if n was 2, it'd be 2 to 100.
If n was what?
So n is just the starting point of the...
No, n is not the starting point. N is the variable of the sequence. Remember yesterday we learned about how to write a sequence in functional form?
Oh, just the number between each of the...
Yeah, it's called the index. You will see that in a minute.
Wait,
Okay.
how do you know the starting point?
I give it to you, right? It's right there. It's right there.
So if you had the starting point of 3, it'd be n is equal to 3, or n is equal to 3.
No, then the sequence would be different, right? Wouldn't the sequence be n plus 2? If you're starting out at 3, okay, and you're going 3, 4, 5, 6, 7, and so on, what's the sequence for this? Isn't it just n plus 2? Yeah, so instead of this n, it would be n plus 2.
Oh.
N would still start at 1.
Okay.
Yes, n would still start at 1. It's a question of how you write the sequence. So yesterday you had a lot of practice writing the sequence. Okay, today we're going to see what we do with the sequence. Okay, how we add things together. Everybody okay on the sigma notation so far? Okay. Here's a lot of abstract looking math. You want to get this down because all the terms in here, all the jargon, all the terminology, you will need in calculus next year. So this guy here, that's called the lower limit. And this guy here is called the upper limit. Kind of obvious, isn't it? One is at the lower end of the sigma and the other one's at the upper end of the sigma. So kind of pretty obvious. You got to know that, okay? All right? And again, like I'm telling you, you're going to see a lot of this in calculus. So let me explain what this means in this context here, okay? We now have an example where we can actually talk about numbers and what it really means. Okay, so get that down. Yeah, in this case, so, you know, it's just a variable, okay? It's just a variable. Sorry? Do you want to wait or you want to go now? Because I have a lot to teach, so it's your choice. Yes, we will have time at the end. Okay, everybody get this down? Okay, can I start explaining this stuff? Alright, so what does this mean, okay? So you're going to start out with k equals 1, so it would give you 1 plus 1 squared. Does everybody see that? Okay, I started out with k equals 1, and so I get 1 plus 1 squared. Is everybody with me on that? The next one's going to be 1 plus 2 squared. Everybody see that? And then the one after that, Keith? 3 squared. And Chris, the one after that? 1 plus 4 squared. And Ashna after that? 1 plus 5 squared. Okay? That's all this fancy thing means, okay? And after that, you guys know how to do this, okay? This is 1 plus 1 plus 1 plus 4 plus 1 plus 9 and so on. Okay, and so on. So all I'm saying is that this is a shorthand form for this, for that. Okay, some fancy math way of writing it. 3 squared. 3 squared be 9. At least in my book it'd be 9. Okay? So everybody okay all right? Okay. Next topic is a couple of properties of sums. Again, I'm going to emphasize to you that you really want to pay close attention to this stuff and really feel the math in there, because you're going to need this in calculus the very first week that you come into calculus. Okay? And you keep using these concepts over and over again. Okay? Keep using these concepts over and over again.